To be here. It's exciting to be a part of this group. We're certainly looking forward with the opportunity to partner with NASA as we build on what we've done from Apollo shuttle station and leverage that into this next phase of human spaceflight. So this morning I have a couple slides to show you the system that we're working on, a little bit of what we accomplished in CCDEV 1, and then our plans for CCDEV 2. So if we can have the first slide, please, and the next slide. So this is the integrated system that we are developing. We're focusing on the design of a spacecraft that will be flown on a proven launch vehicle. Currently we're in the selection process of going through the procurement of that launch vehicle. It will launch from KSC, rendezvous with an orbiting platform such as Space Station or Bigelow Space Complex. It can stay on orbit for up to 6 months to serve the lifeboat function. After its time on orbit, it will then deorbit. The service module is discarded during re-entry. We land on parachutes using airbags on land. The capsule is reusable for up to 10 missions. That's our design point. And then importantly, an integrated piece of this system is a mission control center and the ground processing capability. So as we've worked through CCDEV 1 and on through CCDEV 2, subsequently completing development, we'll be focused on this entire integrated system as a turnkey capability. Next slide, please. This is the schedule that we're working to. Colored in is CCDEV 1. During that phase, we took the design of the integrated system through Systems Definition Review, SDR. And that was completed last November. As we start into CCDEV 2 now, we'll be working through PDR, part of the way towards PDR's preliminary design review, and then part of the way towards the critical design review. There are 4 test flights that are part of our program. Pad abort test that is scheduled in 2013 to test out the abort system, just launching from the ground. And then 3 flights that will use rockets, one that will be an orbital flight test that will put the spacecraft into orbit. It'll operate for a couple days in orbit uncrewed and then re-enter. An ascent abort test that will test the abort system at maximum dynamic pressure, max Q. That's the stressing case for the abort system. And then finally a 2-crew flight test that will happen in early 15. And then we'll be ready for operational readiness later in 15. So those test flights are part of our schedule going forward. The design of our spacecraft is, we're really focusing on keeping it simple, and that's for several reasons. As Phil mentioned, this is an environment where NASA's investment is fixed, and so we need to really control the risk that we have during the development phase. And so selecting technologies that are high TRL allows us to manage that. In addition, having a simple system makes it safe and reliable, and it helps us to keep the operational costs low. So those are really the focuses of our design as we move forward. Okay, next slide, please. These are the teammates that we have as part of our CCDEV 2 team. Airborne Systems will be working on parachutes for us. Ares is doing some. Ares is a company in Houston, strong background in safety type disciplines, and they'll be helping us with loss of crew, loss of mission risk assessments. We've been teamed with Bigelow through CCDEV 1 and now through CCDEV 2. A lot of our testing is done at the Bigelow facility, work on mock-ups, and as a user of our system, also helping us define the requirements. ILC Dover is working on the landing system airbags. Pratt & Whitney Rocketdyne is working on the abort system, the engines associated with that, and the tanks and the integrated system. Spincraft is a provider of the spun-formed domes that we use to build our pressure structure out of. And finally, on the list here is USA, who will be helping us with some flight ops and training activity. In addition, we are teamed with Bigelow and Space Adventures as potential users in the future, and so they're helping to define the requirements of our vehicle as we move forward. Next slide. Just some of, in summary fashion, I'll show you some of the accomplishments during CCDEV. The biggest one, as I mentioned, was we took the design through SDR, a lot of effort in that, and then these are some of the demonstrations we did. About 20 drop tests using the airbags to demonstrate how that system worked. Some uprighting tests. In a contingency, we land in water. Capsules have a condition called stable 2 where they can be nose down. The uprighting test showed that we could upright from that condition. Integrated the life support system to verify we could handle the metabolic load of 7 crew. And then built the crew module mock-up so we could have the crew help us with positioning panels and that sort of thing. More demonstrations on the next slide. If we can switch the slide here. Having an inexpensive heat shield is important to our model because we discard that each mission, so we did some work on new material, new manufacturing process for low-cost heat shields. We fired the abort engine. It's an engine with a lot of heritage. It's used with a different fuel for our system, so we fired it with that fuel and it performed well. We fabricated the pressure vessel structure. Very innovative approach here of building a structure. It has no welds. It's got one joint that is bolted together. It's constructed out of 2 spun form pieces. Another innovation that helps with affordability. And then finally we integrated the automated rendezvous and docking system, which is based on the Orbital Express system that demonstrated on-orbit automated rendezvous and docking. And that's all working well. We'll continue this through CCDEV 2 on the next slide. Importantly, we'll take the design maturity through preliminary design review and then some amount past preliminary design review, but we'll go through a couple of design analysis cycles, some subsystem preliminary design reviews, and then finally the integrated system preliminary design review. And then we've got 13 development test plans. 6 of those we pulled out as demonstrations that will be included as milestones in CCDEV 2. Pratt & Whitney Rocketdyne is developing a lightweight version of the abort engine. We'll fabricate that and fire it. More landing bag air drop tests. This time we'll add horizontal velocity in addition to vertical velocity so we can simulate landing on parachutes. We'll be doing wind tunnel testing initially with the spacecraft as shown there, and then once we select the launch vehicle, we'll add the launch vehicle to those wind tunnel tests. We'll be doing some parachute drop tests, including deploying airbags and landing on the airbags using the parachutes. Expelling the fuel for our abort system is a significant thing. We have to expel all that fuel in 3.2 seconds. And so we'll be doing demonstration of the pressure tank's ability to do that. And then finally, once we select a launch vehicle, we'll be integrating the emergency detection system of that launch vehicle with our launch abort system to verify that those avionics can communicate. So a lot of work planned for CCDEV 2 going forward. Next slide. This is really our mantra here as we go forward. All of our design is focused on delivering a safe vehicle, one that's affordable, and one that can be fielded soon so that we can close the gap that Phil and Ed described up front between the completion of the shuttle program here and the next U.S. ability to carry astronauts to station. And so that's what I had for today. Thanks.
Thank you, John. We have some time for